What do you do in the first one? Let's write it over here so we have some space. Kristen. You have to square 4 and 3. What does it mean to square something? Okay, so what's 4 times 4? You're so good. And 3 times 3? So perfect. X squared. Yeah. Okay. Yep.
From there, you're going to square root the 25 and the x power.
Beautiful.
Which will get you x.
5 equals x. Hey, question mark. What happens when you square root something that's squared? They cancel out, okay? Guys, we have to be proficient at taking the square root of something that is squared. Now, I have another question for you. 99 times out of 100, okay? When we did this in algebra and we physically wrote the square root symbol, we should have gotten 2 answers. Because there's another number that when you multiply it by itself, it gives you 25. What is that number? German? -5. But in geometry, most of the time we're talking about lengths, right? Can a length of a figure be a negative number? No. So most of the time, you're only going to include the positive answer, okay? If you want to make a note of that, please write it down. We are only going to be dealing with the positive result of a square root. Yes, Gio. Okay, the second one. Guys, what did we say canceled out? Square roots and squareds, correct? Do we have a square root that's squared here? What happens when they cancel? You just get 5. So this is 5 plus x squared equals, what's 12 squared? 144. How do I solve this? Subtract 5 from both sides. We're going to get x squared equals 139. What do I do after that? Take the square root. You'll be happy to know you will get your best friend on the exam, aka calculator. So take out your calculators. Can you use your phone for today? Yes. On the exam? No, not even close. Good.
Which exam? Test?
Yeah, a test or a quiz. Okay. You slide it. All right, guys, take out your calculators. And I need you, we're going to go over how to use the square root button because we're going to use it a lot today. So our answer, we are going to be rounding in these lessons to the nearest 10th. Put a note of that. Round to the 10th. So you're going to say x equals 11.8. Why does it round up? Because the number next to the 7 was an 8, right? If the number is larger than 5 or 5, it rounds up. If it's less than 5, it rounds down. Let's talk. Are there questions? Did we all actually practice with our calculators? Amanda, be fast. All right. No. Today's lesson is all about something called the Pythagorean theorem.
I've heard this mentioned a bunch of times.
Okay.
I don't know.
You've probably seen it on TikTok. Okay. You've probably seen it everywhere. It is a very, very, very important lesson. Okay. It is basically one of the building blocks of geometry. Okay.
And
So
we're learning it when the year's almost over. And it's a building block of geometry.
for the next part of geometry. Okay. So it is very, very important. I want you guys to write down a note that's going to carry over this entire lesson. So I want you guys to write at the top, C will always be the longest side. Now, let's go ahead and talk about what the Pythagorean theorem is. So, the Pythagorean theorem only applies to one shape. What is it? Not just a triangle. A right triangle. Underline it, highlight it. Do something to make sure that the words right triangle speak to you. Can you apply the Pythagorean theorem to an acute triangle? No. Can you apply it to an obtuse triangle? No. It has to apply to a right triangle. What is a right triangle?
A triangle with a 90 degree.
With a 90-degree angle. Very good.
Hypotenuse and 2 legs.
Excellent. It has a hypotenuse and 2 legs. Now, the most important piece of information is which side is your hypotenuse. How do you determine what a hypotenuse is in a right triangle? It's the largest side. So in our case, what did I say will always be the longest side? C. So check it out. The Pythagorean theorem says the square of the length of the hypotenuse, in other words, C, is equal to the sum of the squares of the lengths of the legs. In other words, if you're going to make every single side a letter, a squared plus b squared equals c squared, okay? Where a and b are leg 1 and leg 2, and c is always going to be your hypotenuse. Now, how do you identify c in a right triangle? How did I know that this had to be c? How do you know it's the hypotenuse? Excellent, Christian. It is always opposite the right angle, or the 90 degrees. So you can literally go from your 90 degrees opposite your triangle, and that will always be your hypotenuse. It will always be your C value. Okay? They're colorful? Do you like that or no? Perfect. Okay. Now, I'm going to tell you this. The order of A and B doesn't matter, okay? Most students find it helpful to just label the smallest side A and the medium size B. If that works for you, so be it. But sometimes A and B can be mixed around. That won't matter. But the value of C, that totally matters, okay? You have to make sure that you get the C part correct, all right? Okay. Let's check it out. So the next slide are just some common triples. And what this means is, if these were your A, B, and C values, it would work out to a perfect triangle. You'd have no decimals, okay? So these, you don't have to have these memorized or anything, okay? They're just some sets of angle or sides to look for that would complete a perfect right triangle, okay? Just above the 3, put A. Above the 4, put B. And the largest side always has to be C, okay? So let's just do the first one for an example. If you were to take 3 and square it and add it with 4 squared, it would perfectly equal 5 squared, okay? Because 3 squared is what? 9. 4 squared is what? 16. And 5 squared is what? Do 9 and 16 add up to 25? Bingo. So that happens for all of those lists of common triples down below, okay? Now, sometimes when we're calculating the lengths of a right triangle, we do get decimals. Not for the common triples, okay? That's why they're important. Now, if you're one of those people that likes to look at the patterns and the Y's, okay, that's where the core concept comes into play. So this is where they're getting all of those perfect common triples extended. So like you can literally calculate whatever common triple you want going forward. I don't need you to know this, okay? This is just there if you care about that kind of stuff, all right? Okay, next. So we're going to do some examples, okay, where we're solving for y and we're solving for x. Zoom in on letter A. The first thing that we have to do in order to apply the Pythagorean theorem is make sure that we're dealing with what kind of triangle? A right triangle. Is this a right triangle? Yes. Bingo. So I know I can apply the theorem. The second thing you need to make sure is that you label each of your sides. You need to identify what your C is first and foremost. Which of these sides is going to be C? Y. Excellent. It's going to be Y. Now, which one would you make A? 5. Perfect. A will be 5. And which one would you make B? 10. So now, use the Pythagorean theorem because it is a right triangle. What is the Pythagorean theorem? What's the equation? A squared plus B squared equals C squared. So I'm going to write it out for this one. In the future, guys, I'm not going to write out A squared plus B squared equals C squared. Okay, I'm just going to start plugging in. Let's start plugging in. What was A?
5.
So plug in 5. We're going to square it. Plus, what was B? 10. We're going to square it. And what was C? Y. We're going to square it. What's 5 squared? 25. What's 10 squared? And we leave it as y squared. You guys with me? Okay, what do I do next?
Add up 25 and 100.
Okay, what's 25 and 100? 125 equals y squared. Who remembers what to do next? Yes, very good. Take the square root of both sides. Because the square root will cancel with the squared. You guys agreed? So I get y equals, do you know what the square root of 125 is? Neither do I. So that's why we're using calculator. So go ahead in your calculator and do it now so you can confirm that you're getting the same answer. Take the square root of 125 and click enter. It should be 11.2. 11.2 when you round it. Guys, take a moment and check with the person next to you. Check to see that they got the same thing on their calculator, because that's very important. Calculator literacy is a thing. Yes? All right, letter C. So, first thing you need to make sure, can we use the Pythagorean theorem? Why? It's a right triangle. Perfect. Put a check mark. Second thing you need to make sure is what? A, find your hypotenuse. Which one of these is my hypotenuse?
C.
We know it's C. Elias? 3 times the square root of 2. Very good. What would you make your A value? X. And your B value? Tres. All right, plug it in. So it's going to be x squared plus 3 squared equals, hey, be careful here. It's 3 times the square root of 2 squared. Now, I'm going to show you 2 different ways to do this problem, okay? If you forgot the exponent rules or the power rules from algebra, pay close attention. Do you guys agree that that 3 and that square root of 2 are being multiplied inside the parentheses? What happens with an exponent on the outside is that exponent becomes the exponent. It gets multiplied by the exponents on the inside. So watch. It's going to be x squared plus 3 times 3 is what? 9. This becomes 3 squared and the square root of 2 squared.
Where'd you get the square root for the 3? I meant, where'd you get to square it?
Because that's our formula. Remember, you're squaring each of the sides, so a squared plus b squared equals c squared, okay? Yes. Anything that doesn't have a visible exponent, its exponent is 1. Yeah, 1. It is going to be 2. Very good. Okay. So this is going to be x squared plus 9. What did I say happened when you had a square root and a squared? They cancel. Now, 3 squared is what? 9. But if those cancel, we're multiplying 9 by how much? 2. All right. So let's go back. Now it's going to be x squared plus 9 equals 18. What do I do to solve for x? Subtract 9 from both sides. And we're going to get x squared equals, what do I do? Take the square root so that the squared and the square root cancel. You get x equals, what's the square root of 9? 3. Now, let me show you a trick, okay? This trick involves using your calculator, so we're going to be very proficient with our calculators. Moving on. So, we got to keep going. So, the next example we're doing is we're going to find the length of a diagonal of a rectangle with length 8 and a width 4. Were we given a diagram? Nope. What should we do? Draw one. So, to the best of your abilities, draw a rectangle. This side is going to be 4, and this side's going to be 8. What do we know about rectangles? What do we know about rectangles?
They're parallel.
They're parallelograms. Very good. What else do we know about rectangles? Opposite sides are congruent. So I can put an 8 down here and a 4 over here. Who said something about the angles? What'd you say? Yeah, they all have right angles. So let's put 90-degree angles on all 4 of the angles. Anything else?
It's a quadrilateral.
So what, quadrilateral? I think that's good enough, right? Now it's asking us to find what in this rectangle. What's a diagonal?
Something that's like next to the
What?
right angle.
An intersection?
Yeah.
Okay, what's a diagonal? By definition, what's a diagonal? I see some people like they're putting their arm like diagonally. Yes, that's diagonal. What is a diagonal in a figure?
45 degrees.
Not 45 degrees, doesn't always have to be. Yeah. It connects not two opposite sides, angles or vertices. So go ahead and draw a diagonal. There's 2 possible diagonals you could draw. I'll just draw one of them. Remember, a diagonal goes from a vertice to a non-adjacent vertex. From one vertex to a non-adjacent vertex.
It's a right triangle.
So now we are dealing with a right triangle. Do you see it? Do you see it? Okay. Make this X. What is my A value? What is my B value? What is my C value? Very good. Can we use the Pythagorean theorem? Yes, because what kind of triangle did I say we were dealing with? A right triangle. So check it out. What am I going to set up? 4 squared plus 8 squared equals x squared. All right, what do I do? 16 plus 64 equals x squared. What's 16 plus 64? 80 equals x squared. How do I solve this guy? Take the square root of both sides. Do you know the square root of 80? No. Me neither. So what should we use? Calculator. So we're going to take the square root of 80. What do you get? 8.9 equals x. Do we care about the negative value? No, because length is never negative. Hey, question people. I want us to be literate. Like, not literate. I mean, yes, I do want us to be literate. But I want us to be like, understand like common sense, right? Like, what does this number mean? 8.9 is really close to what number? 9. What is 9 squared? 81. We just took the square root of what number? 80. That's also really close to 81, right? So wouldn't it make sense that their square roots are really close to each other? Think about that, okay? 8.9 approximately squared gives us 80, right? So 9 squared gave us 81. Those are both close. Do you guys see that? If you take the square root of like 7 and you get 456, is that close? No, you did something wrong with your calculator, okay? You need to have a sense of like, what number should I be getting? Because then it makes sense like I'm using my calculator correctly or something's going wrong, okay? Am I good? Did I lose anyone? Okay, let's move on. Who said yes? Yeah, go ahead. Kristen, what's up? Okay, what's 9 squared? 81. So if we're finding the square root of 80, which is just less than 81, do you agree we should get a number close to 9? That's all I care about, is that we got 8.9. Okay? All right, moving on. So the diagonals of a rhombus have lengths 16 and 30. Find the perimeter of the rhombus. All right, so what is a rhombus? It can be a square, but not all the time. It's a parallelogram, okay? So we know it has parallel sides, okay? What else do we know about a rhombus?
It has 2 diagonal sides.
Okay, it has 2 diagonals.
And they're parallel.
Wait, what? Opposite sides are congruent. Not just that. What makes a rhombus a rhombus?
90's in the middle.
Yeah, it has 90-degree angles in the middle. But guys, it's the most important piece of a rhombus. No.
Angle bisectors.
All the sides are congruent.
Congruent.
So, hey peeps, if we're finding the perimeter, how many of those sides do I need to find?
One.
Just one of them. Because if they're all the same, what can I do to find the perimeter then?
Multiply by 4.
Multiply it by 4. Okay? So, check it out. Do you see a right triangle anywhere?
Yeah.
Yeah. Is this not a right triangle right here down at the bottom?
I see 4 of those.
There's 4 of them. You can use any one that you want. I'm going to use the one at the bottom. Now, it gave me one other piece of information. It told me that the diagonals, that the diagonals were how long? 16 and 30. Guys, we want to figure out what our A length needs to be, what our B length needs to be, and what our C length needs to be. We need 2 of them to apply the Pythagorean theorem. What do you think A is?
8, 15.
It's 15. How did you get 15, Hayden? You divided 30 by 2. Remember, diagonals in all parallelograms, they bisect each other. Okay? What about the length of B? 8. Very good. So A is going to be 15, B is going to be 8, and C is our unknown. We're just going to leave it as C, okay? So we're going to set up the Pythagorean theorem. We're going to set up 15 squared plus 8 squared equals C squared. All right, 15 squared, we have a calculator for a reason. Use it. I believe you get 225 plus 8 squared, which is what? 64 equals C squared. When you add these, you should get 289 equals C squared. Take the square root of both sides. I think you get 17.
Yes.
17 equals C. But remember, that C value is only one of my sides. The perimeter is each of these sides added together, correct? So 17 plus 17 plus 17 plus 17. In other words, 17 times 4, which gives you 68 units. Hannah, what's up? You can make A either 15 or 8. The only thing you can't make A is 17, okay? The C value is the one that matters the most. How are we doing? Carson, go. Are we okay? All right. Let's do this one. Example 4. You guys. What? You're missing a slide. Oh, we're missing a side, yes. Missing 2 sides, actually. So, guys, the whole pink triangle, is that a right triangle? No. But I want you to look at that first. What do you know about the entire pink triangle? John?
There's a triangle inside of it.
There are 2 triangles inside of it. Very good. Those 2 triangles happen to be right triangles. But before we do anything, look at the whole thing. Hayden? The other side is also 90. Okay, that's a good observation. Sophia? It's isosceles. How do you know it's isosceles? Both of the x's. What do you know about isosceles triangles? two equal sides, what else happens do we know about isosceles triangles? The base angles are congruent. So now, do you guys see what just happened here? We now know that both of those two right triangles have to be the exact same triangle, right? Because these two sides match up. The x's match up. That makes these two sides also congruent. Now, if those two sides at the bottom are congruent and the whole length, guys, this 6 represents the whole length. If that whole length is 6, what are those bottom pieces of the triangle? 3 and 3. So look at one of the right triangles. Go ahead, German. Barbara, after one of them, okay? What can I set up using the Pythagorean theorem? Nick? 3 squared plus 6 squared equals x squared. Very good. We're going to make this my A. This will be my A, this will be my B, and this will be my C. So it'll be 3 squared plus 6 squared equals x squared. 3 squared is 9. 6 squared is what? 36. And x squared. Add them together, you get 45 equals x squared. What do I do next? Take the square root. Do you know the square root of 45? Me neither. What do we use? Calculator. Take the square root of 45. Guys, make sure you're being proficient. Do it right now on your calculator. You should get 6.7.
So A will always be our smallest?
No. Hey, I hear a few people saying that. Does A always have to be the smallest side? No. The only one you absolutely care about is which one? C. And C has to be what? The largest side, aka the hypotenuse, okay? That's the only one that really matters. A and B, you can flip them around. It's not going to change the equation, right? Because 3 squared plus 6 squared is the same as 6 squared plus 3 squared, right? Those don't matter. But C absolutely matters. Any other questions? Yes?
You really have to round them to the nearest 10 if they ask it?
Correct.
Okay, only if they ask, right?
If it doesn't ask, just round to the nearest 10th. 10th is like our go-to, okay? We're going to round pretty much everything to the 10th power, or 10th place, okay? All right. What do you think the converse of the Pythagorean theorem would be? Christian?
C squared minus B squared equals A squared.
No. C squared minus B squared equals A squared? No. Hayden? If they don't tell you what? What's parallel? Not parallel. You're on the right track though, yeah? No, not with the square root, yeah? No, yeah?
C, the sum, C squared.
No, don't read the next slide, Hannah. Guys, what did I say? John?
A2 minus B2 minus
No, yeah?
Well, wouldn't you have to find the other side, the legs?
Okay, I have a question for you guys.
I wasn't reading the next.
What shape did I say you could use the Pythagorean theorem for? So what if you didn't know if it was a right triangle?
It's the same thing.
So, if A squared plus B squared equals C squared, if you know this, then you can assume the triangle is what kind of triangle? A right triangle, okay? So, I know the wording's small. I can't zoom in any further, guys. I'm sorry. Oh, wait, actually, yeah, I can. Is that better? So,
Triangle is
there we go. So guys, the big thing here though is that C has to be what side of the triangle? The biggest side, okay? Now, if you square that side and it's equal to the other two sides squared and added together, it is a right triangle, okay? This is the converse of the Pythagorean theorem.
so it's the same thing.
It's the same thing, but we don't know that it's a right triangle to begin with. Our hypotenuse and our conclusion are switched. What's that?
You have to prove that it's a right triangle?
Yeah, you can use this to prove that triangles are right triangles. Mm-hmm.
It's the same thing.
It's the same thing, just in reverse. Yes.
How would that
So maybe it gave you a triangle. That's a very good question. Christian asked, how would this help me prove it? Let's give you a triangle without a 90-degree mark. And I told you this was 5, this was 4, and this was 3. And I said, tell me what kind of triangle this is. What would A have to be? Okay, you can make A 3. What would B have to be? And what would C have to be? If you square 5, what do you get? 25. 3 squared is what? 9, right? And 4 squared is what? 16. What's 9 plus 16? 25. Do A squared plus B squared equal C squared? So in other words, what do I know about this triangle now? Now my conclusion is that it's a right triangle. Do you see the difference there? Using the regular Pythagorean theorem, we knew 2 of the sides. We were figuring out the third one because we knew it was a right triangle. Okay?
This one figure out the right triangle? If it is.
Pythagorean inequalities theorem. What happens if C squared is not equal to A squared plus B squared? It's not a right triangle. Now, it just so happens if C squared is less than A squared plus B squared, it is an acute triangle. What is an acute triangle? All of the angles are smaller than 90. And that's when C squared, when the longest side squared is smaller than the other 2 sides squared and added together. What do you think happens when C squared is bigger than A squared plus B squared? It's an obtuse triangle, okay? So the obtuse happens when you square C and it's larger than A squared plus B squared. Guys, so when we're determining whether a triangle is acute, right, or obtuse, and we're given 3 of the sides, this is what we have to do. I only know one of my sides for sure. Which one do I know? C. Which one has to be C? Look at letter A. 29. That has to be C. Do A and B matter? No. So we're just going to write A over here and B over here. So what we're doing for all of these problems, guys, is we are going to take C squared, put a blank, and we're comparing it to A squared plus B squared. So in letter A, what was C? So we're taking 29 and we're squaring it. And we're comparing that to 20 squared plus 21 squared. Does someone use their calculator, tell me what 29 squared is? 841 is correct. What's 20 squared? 400. And what's 21 squared? 441. What do you get when you add 400 and 441? So 841 and 841. How are these 2 numbers related? They're equal. If A squared plus B squared equals C squared, what kind of triangle do we have?
Right.
It's a right triangle. Are we okay? If they're equal to one another, it's a right triangle. Let's do letter B. In letter B, the only thing that changed is what? The hypotenuse. The hypotenuse is now 30. So we're going to take 30 squared, and we're going to compare it to 20 squared plus 21 squared. What's 30 squared? 900. How does that compare to 841? Ah, very good, Christian. This means it's an obtuse triangle. Okay? When your c squared is larger than a squared plus b squared, think about bigger, obtuse, big angles, obtuse. So that would be an obtuse triangle, okay? That would be an obtuse triangle. You guys with me? Try C, D, and E on your own. Go.